control is we try to put at the end user, which is the house connection. The house connections is before the meters, to put a shut-off valve that we can control. And we can close as the rational supply we want, usually like 24 hours, 48 hours. After finishing, we close it, but we keep the water in the network. Of course, later on, we try to reduce the pressure through pressure reducing valves. And in these situations, we will stimulate the 24-hour with less pressure in the system and delivering the water on the rational supply. And the benefit of that will be explained later by Pampus. So with having this, we can apply all the non-revenue measures on the network through even leak detections, better isolations, if there is problems, illegals, and etc. So to explain the concept, how it's happening under the current, I would need to explain here. Under the continuous, under the intermittent water supply, assume an area which is colored in orange and blue. We have like, assume in a week, we have 50% of the time we have a supply and 50% of the time without supply. So we will need, and we are assuming here that the demand is met. So the blue color is the consumption delivered to the people. So we supply for 50% of the time. The quantity will be the total amount here, which is 32, for example, cubic meter or unit of water, which is both the blue and the orange. The orange will be the leakage, because we supply, we meet the demand, and the remaining under intermittent supply will be those. Now, but for the remaining of the week, which is the 50% of the time, there will be no supply in the network. Now, if we shift it to continuous supply, again with the assumption that demand is met, we still have the same quantity, which is the blue, and we will have, usually, because you increase the supply durations, the leakage will be double or increase. And because we say 50% more time, the leakage will be doubled, which is the gray, which is the color in orange, and the orange in hashtag. Now, part of that we can recover. Potentially, you can maybe recover another 50% of it and maybe more. So we still having, after adding putting the non-revenue measures, we still recover part of the leakage, and we could supply the same quantity before and after. Now, this is the easy part. I will not maybe go to this difficult part, but the idea of the difficult part that under conditions that we supply 50% of the time, but the demand still not met. We need more time to supply. That's where we'll have part of the demand not met. But if you want to switch to 24-hour to meet the demand, the case that here the 32 unit water is delivered, but still there is another 8 has to be delivered. So when you switch to 24-hour, we will add another 8. That means you have 40 cubic water unit delivered. But again, the leakage or the losses, it was here at 16. It also doubled because of the duration is extended. Then you can recover part of it. But this is just an assumption for a case. There will be many cases, could be different approaches. Now the idea is how the downstream control work, and how we will apply all the non-revenue measures on downstream control will explain in the following slides by my colleague, Pampus.
Good morning, everyone. Thank you, Mr. Chair, for the introduction. Thank you all for being here. First of all, I would like to thank WMI for giving us this opportunity to try this innovative, in my opinion, approach. And thanks to our colleague Mohammed Shafi, who is also a great contributor, to this idea. Now, why downstream control? Personally, I am a strong advocate of transitioning to 24/7. from intermittent water supply. But in being of the region, of the Middle East region, and traveled to a number of countries with intermittent water supply, I always get, the answer that, well, it cannot be done. We don't have enough water. So there must be another way of actually doing away with the detrimental effects of intermittent water supply and still supplying the customers with the same volume of water that we do supply under intermittent water supply. So we thought of this idea of downstream control, and in the next few months, we are going to try in a couple of pilot areas in Jordan this idea. So hopefully, we'll have some results, to show to you of this idea that we're presenting now. Downstream control allows water rationing. Yes, as Tamer explained, we control at the customer level. So there has to be a mechanism there, and we'll talk about it later on, that we control at the downstream level, at the exit point. We have many exit points. So you'll be wondering, well, how can we do this? And we'll give you some details as to how we're thinking of actually controlling at each customer the water that we give. We can do it either by volume or by time. Now, this is a choice that we have to make along the way. But the idea is to maintain the system full of water. So we don't empty and refill, and I'm not going to go through with the detrimental effects that we have emptying and refilling. Tamer already covered those. So control at the customer level, either using time, so many hours, or using quantity, so many cubic meters or liters per customer. Now, if we do that, what kind of benefits do we have? What can we do as a utility in order to improve the situation? So we have control, bear this in mind. So we have given our customers the volume of water that supposedly they were getting under intermittent water supply. But we will be giving it in a more efficient way. We could actually control the volume that we give to each customer so that there is some kind of equity. Because what we are facing now is that customers at low elevations, they get more water. Customers at high elevations, they may get water. I did come across cases, where customers do install suction pumps. So as soon as the water comes, let me get the water first. So we will do away with these many problems in the network. So the customer side is taken care of. What do we do with the network? This is the beauty of this particular process of downstream control, that we can do a number of things that we were not able to do under intermittent water supply. And one of those things is to manage pressure. As you can see on this particular slide, on the right-hand side, I don't think the pointer is showing, but on the right-hand side, you will see the pressure, minimum 0, maximum 2 bars. The valves are black at the customer level and they are closed. So once we don't supply water to the customer, what can we do? We can reduce the pressure in the network. Not empty that part of the network, but reduce it. So the only pressure in the network is the static pressure given by the elevation in that particular area. But at the very, very high point, we just maintain 0. So we maintain pressure at 0 level. In the rest, the other areas, we can continue and we can control pressure. We can actually do pressure management in supplying the water to our customers. So pressure management is possible under this condition. What next? We meter the water going in because we have continuous supply. So we can have a nice graph. And we'll be able to analyze the minimum night flow. And again, we can see here again on the right-hand side, flow rates. When the valves are closed, you can see the valves all closed, being of black color. It's leakage plus unauthorized consumption. UAC. So the water that goes through when the valves in that particular area, customer valves, are closed, it's equal to leakage plus whatever unauthorized consumption we have. If we don't have unauthorized consumption, that means the minimum night flow equals to leakage. And this is information that we get additionally using downstream control that we don't have when it's under intermittent conditions, because we don't have this particular flow pattern. What can we do with this? We can do active leakage control, acoustic leak detection. In the section of the network that is closed and we have leaks, we can do the acoustic leak detection using standard methods of leak detection. And therefore, it becomes easier to find leaks because the network is under pressure. We are not supplying to the customers, so we have no noise given by the water going through the service connections to the customers. So mainly the noise will come, from the existing leaks. So active leakage control, it's actually possible under this condition. And of course, we can use a very traditional method that we used to use, at least at my early days, in water management systems, of step testing. Step testing is a great way of actually finding out where to start your leakage activities. So you can see from this graph that we have 4 steps, S1 to S4. And as we are reducing the water going, as we are rather closing each step, we are reducing the water going into this area. Now, what is the beauty of these things? The beauty of these things, we can do it very easily because all the customer valves are closed, so we don't have actually consumption. So any water that is lost, it's either leakage or unauthorized consumption. So we can see and we can prioritize in this particular example that we put, step 2 and step 3 are the ones that we should be looking for with priority step number 1. So we can go with step testing and actually find out the leaks in the network that we cannot find under intermittent water supply. Now, I've just highlighted very briefly the benefits of having downstream control without actually doing anything out of the ordinary. All these things, we are doing them when we have continuous supply, or some of them, we may be doing them under intermittent water supply. But how could this be possible? Well, we need a gadget. We need this downstream control valve, and you can see a typical picture of this. Where do we install this? Just before the customer meter. It could be an integral part of the meter, but we'll come to that. Now, this is a solution that it can work either locally, it's an automatic valve, or we can, if we want, at the end of the day, to link it to the meter so that we can have either time or volume control. Now, this technology is available. However, it does not have wide use and is still expensive to some extent. So we will need to work on this and try and convince manufacturer that this is something that will have a wide commercial application, so that there will be more manufacturers coming in, although as you can see from this particular slide, there are a number of manufacturers which actually produce this kind of technology. So the knowledge in this particular technology is there, is available. We need to commercialize it. And of course, you may have seen it, and I've seen it in some cases, being applicable in prepaid meters, for instance. I know that in some parts of the world, in some countries, they're pushing with this prepaid meter, which actually does very similar thing. It links an automatic valve to the meter. Now, challenges. we do have challenges. It's not easy. And hopefully, through the pilot projects, we will be able, to have the data and information available to actually convince people. First, the utilities. We need to overcome, this resistance from the utilities for anything new, anything innovative. We don't like to shift out of our everyday work. So we need to overcome this reluctance. We need to convince of the many advantages. And hopefully this presentation has done this to some extent, and the pilot projects will give you more evidence. And of course, we need also to convince the customers to cooperate with us. So with this, I'd like to conclude this presentation by saying that technology is available. We need to push for the price to go down, and of course, we need funding in order to be able to convince that this is a way forward. Thank you very much.
Thank you, Babos. Thank you, Damer. We'll have 5 minutes for questions, if there is any. Microphone. Lady.
مرحبا. Thank you so much for your presentation. بدي أسأل على التكنولوجيز إنه why should we search, why should we pay and bring funding for for the technologies? Why can't we actually enhance our capacities here in Jordan, and we have developers that may we work with them and they can instead of using the funding for buying the technologies, that we can train our resources here in Jordan.
We have all questions. Yes, sir.
Thank you. Actually, I'm very happy and proud that WMI take the initiative for bringing this technology to Jordan. One day in 1985 or 86, I was director of operation of water supply and sewer system. And there was 2 schools in Jordan that time. One of the schools that continuous supply will save water, will not leak the water. The other school is different. I remember my wife and me was living in Third Circle in Amman. And in that time was intermittent supply. My wife was putting the water, storing it in the baño. And we bought a special tank and put in veranda to store the water. When the rotation came to another day or after 3 days to our house, all the old water was thrown to the sewer system. Exactly, that was practically my house. So I am very proud that WMI is bringing this technology to Jordan. And I am sure that we will save water and you will save money and you will save diseases. We will prevent diseases to Jordan. And hope we will be successful, but I am afraid from reluctant people who again don't like changes. This is, you will have really big challenges to convince the people who will say, no, we will waste the water, no, we don't have the water. So this is your challenge. I hope you will be successful in that. Thank you very much.
Thank you for the remark. Thank you. Okay, yes, please. Okay. Thank you, sir.
Again, thank you very much for a super interesting presentation. The question I have is if you see, in an ideal world, the downstream control as an interim solution to fix and identify the leaks in a system so that it's manageable to provide continuous service, or if you see it as a permanent solution that would be in the system for continue or in the future.
Masri?
I would like to ask 2 quick questions about the roof tanks. This will be also dealing with the roof tanks. We know that the roof tanks is like 10% or 15% causing these losses. Second one is about energy saving. Does this make energy saving, or we will pay more because it's a pressure. Whenever you add something and you get it without having water, this will be causing more energy consumption.
Thank you. Tamer, Pampus, please.
Right. We'll respond, the same order as the questions were asked. The question about the technology and training taking place in Jordan. The idea so far, and you will see this in the next session with the NRW master plan, is that we don't bring something and we adapt to it, but we rather take what we have and we adapt solutions to our particular situation. This is how we achieve sustainability. So if knowledge and know-how is